recording. And so today we're going to talk about EMF inspections during a home inspection. And we have Oram Miller. And Oram is a certified building biology environmental consultant and electromagnetic radiation specialist. And he's from Los Angeles. Oram, are you with us?
Yes, I am, Ben. Thank you for inviting me.
Oram, thank you so much. I'm going to give you controls.
Okay.
So you can take over the presentation for us.
How's that? Can you see my screen?
Yep, looks great.
Okay. Well, welcome everyone. As Ben said, my name is Oram Miller. I'm a certified building biology environmental consultant, or BBEC, and electromagnetic radiation specialist, certified by the Institute for Building Biology and Ecology here in the United States. I have worked with home inspectors for years. I get a number of referrals from them for their clients who are interested in electromagnetic fields. So why is this something that people should pay attention to, particularly home inspectors? And you're going to find out in the next hour. It's because people are either electrically sensitive, which and those types of people comprise 60 to 70% of the people I work with as a building biologist. These are people who already know that they have symptoms that are related to the field that they're exposed to in homes, or if they're so sensitive that they can't go into a Starbucks or a library or a friend's home that has Wi-Fi on, they need help figuring out how to be connected to the world through the internet with Ethernet cables without Wi-Fi. Maybe they're sensitive to the magnetic fields that they have from wiring errors in their home when they turn their overhead lights on. Maybe magnetic fields from power lines outside the home, or electric fields where they sleep from the voltage, not the current, the voltage from plastic jacketed Gromicko circuits, or even if they have metal clad wiring, from the cords that are plugged in within 6 feet of the bed. So these are some of the parameters that we deal with, and there are people who are sensitive and symptomatic from these fields who don't know it, and that's something that is of great interest for countries outside the United States that pay for the health care of their people. There are countries, believe it or not, that are actually engaged in taking Wi-Fi out of schools and hospitals and libraries. It's actually illegal now in this country of France in the last 1 year to have Wi-Fi in any daycare center or nursery for children where children under 3 are present. And if you're a school teacher in grade schools there, you have to turn the Wi-Fi off when it's not being used. You can't leave it on standby. So that begs the question, what do they know that we don't know here? Or what are we not being shown by media and by regulatory agencies and such? Why do these other countries, why would they enact this type of legislation? Well, we'll get into that here. So my job as a building biologist is to help my clients who call me up, and I literally have not advertised in all the years that I've been here in Los Angeles for the last 6 years, and in Minneapolis, Minnesota before that. I don't need to, because word of mouth and my website bring enough business to keep me going. And every day when I get home from going to somebody's house and coming back on the highways, freeways of Los Angeles, I have a couple of hours of work at the computer to do for answering questions from people who email me from all over the country and from clients and committee work for my profession. So it keeps me busy, and there's quite a bit of interest in this, and it's growing. I am part of the faculty for my profession, so and we have some summit webinars going on now through the Green Home Institute, which I'll explain to you. So this is who we are. We are certified by the International Institute for Biobiology and Ecology, which is now called the Institute for Building Biology and Ecology in Florida. It comes from Europe. And an architect by the name of Helmut Zia brought this knowledge to the United States more than 25 years ago. And I'm one of 120 certified building biology and environmental consultants in the United States. Before I go any further, I want to mention that I will be a speaker at Inspection Universe in Orlando, the conference that NACHI is hosting in March 13th through the 16th. I'll be speaking on Tuesday morning March 15th at 10:15. I'll be one of 4 panels or seminars that are held at that time for about an hour and 45 minutes. So what you're seeing here is the slides that I'll be presenting there. We don't have enough time by any stretch of the imagination to go over all the slides here, but I'm going to go over the important ones. I will post this on my website under EMF lecture slides as soon as we're done, so that you can go through them carefully and in sequence, so you can see the research and the information that's presented there. But if you're coming to Orlando, we'll have almost 2 hours to go into this in great detail, and I'll answer a lot of questions there. So I hope to see many of you there in Orlando next month. So the seminars that my profession provides, for those of you who may develop an interest in taking them and becoming a building biology environmental consultant or electromagnetic radiation specialist in addition to being a home inspector, and we have many electricians and physicians, interior designers who come through our training programs. So we'll be holding a series of seminars. We do this every year, and they're coming up. Just in the next couple of weeks, we have the Building Physics, Building Biology Principles, and Natural Building Materials Seminar in Santa Fe, New Mexico, February 29th to March 4th. Following that, we have the Indoor Air Quality Seminar, the 211 Seminar in May in Wisconsin, and then back in Santa Fe in August, we have the Basic Electromagnetic Radiation Seminar that I helped teach in August 16th to the 21st. And then this December, we have the Advanced EMR Seminar, which follows the basic one, and that's every other December, so that'll be this year, and I'll be helping to teach that as well. So you can become a certified building biologist in addition to being a home inspector if you're interested. Now also, I mentioned these webinars on reducing occupant exposure to EMFs in residential construction, and that's hosted by the Green Home Institute, formerly the Minnesota Green Star program. When I lived in Minneapolis more than 6 years ago, I gave a lecture on this topic, EMFs, and one of the attendees said that he had been asked by the Builders Association of Minnesota and the Minnesota chapter of NARI, the National Association of the Remodeling Industry, to come up with a homegrown set of standards for the climate in Minnesota because LEED for homes hadn't been developed yet. So they asked me to provide guidelines and a checklist for EMF reduction because electricians were being asked about this by their customers, their clients, and they didn't know what to do. So we provided them with guidelines, and that's now part of the checklist, which has now gone to other states, Michigan and New York and Ohio, as part of the Green Home Institute program. And we're in the middle of a 6-part webinar, one per month. We have had the introductory webinar, I believe that was in December. Then we had the magnetic field webinar in January, given by one of my teachers and colleagues, Bart Burmaster. I will be presenting the electric field webinar next week on Wednesday. I believe that's the 24th. And then we have another 2 webinars on radio frequency EMFs, and then finally dirty electricity, presented by 2 other gentlemen who were part of this panel. And you can see or listen to the past webinars and sign up for the future ones. It's free. You get credit through these agencies down here. And go to my website, createhealthyhomes.com, and then click on Oram on the radio and video, and you'll see instructions there on how to sign up for this. So the goals of our profession are to find and reduce sources of toxicity in the home or office, and that includes indoor air quality, electromagnetic fields, and outgassing for building materials, where our intention is to strengthen the client's tolerance to these influences outside the home and reduce them inside the home, because you can't change the external environment, but we can help people to tolerate them better. And I work with people who are really sensitive to these toxicities, mold, chemical outgassing, and electromagnetic fields. And we do this by reducing exposure to these toxins and creating as EMF-free or reduced a sleeping environment in particular as possible. So, as I mentioned, I have there are 2 groups of clients that I have. The 2/3 of them are already electrically hypersensitive. They know that about themselves. They notice a difference when they're outside the home versus inside the home in terms of their symptoms. And 2/3 of them are symptomatic. So that's half my clients. The other 30% of the first group are people who are not sensitive or symptomatic, but they are health conscious, and they're worried about this. So I get a lot of calls, probably 1 or 2 a week, from someone who's interested in buying a house, and their realtor or their home inspector knows of me and recommends me as a consultant to come in for that consultation. And I'm very clear to say to people, I don't do home inspections per se in the traditional sense. You have to hire a home inspector for that. I do a supplementary or supplemental inspection for the fields. And power lines is their concern. They see transformers, which are never a problem because the magnetic field from transformers, the gray can up on the pole, doesn't extend more than 3 feet. But the wires that lead to it could be a problem, and we'll talk about that. So there's always a balance between the sources of EMF toxicity and diet, heredity, stress levels, healing modalities. So I tell people that I can't guarantee any outcome in terms of reduction of their symptoms, but I do say to the degree that your symptoms are caused or maintained by the elevated fields that I measure, and to the degree that we're able to reduce them, that's the degree to which you can expect improvement. You really don't know until after the fact. But I have a track record. We do see a reduction in symptoms in the vast majority of people we work with. So that's encouraging. And I tell my students, happy clients bring more clients. I get more referrals just from word of mouth from my clients and my website than any other source, but also from healthcare practitioners and home inspectors. So here are the causes among the general public. To put it in perspective for all of you, really only 3 to 5% of any given country's population is known to be electrically hypersensitive. Now in Sweden, they take that seriously, and there is that's listed. Electrical hypersensitivity is a compensable disability in the Swedish healthcare system, which is very interesting. And they're recognizing it more throughout Europe. But researchers outside the United States, because there is hardly any research done on this in this country, researchers in this topic, in this field, they estimate that up to 1/3 of the population at large is symptomatic from the use, particularly of wireless devices. Everyone has cellular damage to their brain and to the cells that are close to the transmitter, more than 5/8 of an inch, from wireless RF exposure, radio frequency exposure. So 2/3 of the population can repair the cellular damage at night and do not become symptomatic, just as with cigarettes. Not everyone who smoked developed chronic obstructive pulmonary disease, or COPD, or emphysema, or lung cancer. But everyone had damage to the lining of the lungs, but they could repair the damage in half of the cases. But the other half didn't, and maybe 1/3 of the people who are exposed to these fields develop symptoms. So it's all about risk ratio for those who are asymptomatic. And that's why you folks, the 2 reasons why you folks should be interested in this is because you will have clients who will ask you about it, maybe a few throughout your career, but there will be some. And you can either recommend a building biologist in your area or take some of this training yourself. And the other, for the general population, there's this whole question of what is considered a safe level. We have guidelines, which I'll show you, but it's a matter of risk ratio. Like now we know not to smoke cigarettes. It's very few people do, and you can't smoke in public places, but that wasn't the case 30, 40, 50 years ago, of course. There's been a shift. The same thing will happen with EMFs, particularly with wireless devices, as you will see that over the years to come. So there are 4 types of EMFs. We have AC electric fields, that means alternating current. Electric fields and magnetic fields, which you'll see in a moment, are both present when electricity is flowing through wires, such as you have here, but they are at right angles to each other and they're independent or connected depending on what frequency you're at. And then the third is radio frequency fields from wireless devices, and the fourth is dirty electricity. So here's what I was talking about. The direction of the, so this is the x-axis time actually, and we have an electric field component, which is the vertical in red, and we have the magnetic field component, which is horizontal in blue. And they're at right angles to each other, as you can see here, and they're independent at the frequency of house wiring at 60 hertz, because you're in the near field. And because the wavelength for 60 hertz is 3,000 miles, so you're always, and the wavelength, I'm sorry, the far field begins at 3 wavelengths, which is 3 times that, so that's 9,000 miles. So you're always in the near field, and you will always have uncoupling and separation of these 2 fields. So magnetic fields are the M of the EMFs, and the electric fields are the E of EMFs. They're both there, and most people don't pay attention to electric fields. These fields come from power lines, from circuits in your walls, and power cords at night. And they enter our living space and can affect our health. And just as an aside, or I'll get to it, the magnetic fields are not stopped by metal clad wiring. Electric fields are if the cladding is grounded at one end and continuous, but not the magnetic fields. They'll go right through the material, metal, aluminum or steel for your flex, your EMT, and so on. So we'll get to that. So here we have Nearfield and Farfield. Farfield is defined as 3 wavelengths out here from the source. Within the near field, the electric and magnetic fields are uncoupled. And as I said, the wavelength for 60 hertz is 3,000 miles, so you're always in the near field there. So you have to measure the electric field and magnetic field separately when it comes to house wiring. Now here's a spectrum. We have 60 hertz would be down in this area where power lines are, and then you're getting into the radio frequency waves, really with the light green, the tan, and the brown here, and going from AM radio to FM up to microwave frequencies for the wireless devices that we have that are in the 800, 900, 1800, 1900, 2400 megahertz range. Then here's a summary. Electromagnetic fields are considered harmless by industry, but they are a significant health risk, like cigarettes were, and the companies are really in denial, and there's a reason for that. I won't go into that, but there's a lot of politics and a lot of money involved. That's really what it comes down to. Most research comes from Europe. These countries here are limiting Wi-Fi, and there are more. I have another list further down. The U.S. is promoting Wi-Fi for everything. Consumer Electronics show in Las Vegas every January has now deemed us to be in the era or the age of the, quote, Internet of Everything, where you have wireless connections for connecting everything in your home from your smart device. If they can think of an app and an application, they'll find a way to get that information to your smartphone and your iPad, and so it's all wireless. But EMFs do interfere with healing and treatment from healthcare practitioners or that they provide, and the EMFs get in the way of that. And I know this because my clients tell me that when we reduce the electromagnetic fields that we identify, their symptoms get better and their treatments are more effective from their healthcare practitioners. So as I said, most people do improve with reduction in EMF exposure. Now here are some of the agencies outside the United States that are doing research on this. The International Commission for Electromagnetic Safety, headquartered in Italy, but it's an international body. The Swedish Association for Electrosensitive, PowerWatch in the United Kingdom, International EMF Alliance, there are more. And here's a great summary. This is Dr. Martin Blank. He's spoken at our conferences. He's a retired professor from Columbia University in New York, retired now, so he can talk about his research. And he lives in Canada. He lives in Vancouver. And he has written a book called Overpowered, talking about the research that he did at Columbia on the effects of low power wireless devices, or the low power frequencies from cell phones and the like next to your head on DNA in cells. And he has headed a group of 200 scientists from around the world who have done original research on this, who are appealing, last May, appealed to the United Nations and the World Health Organization, and they're from 39 countries, so you go to emfscientist.org to learn more about that. Unfortunately, there has not been a response, not surprising, but at least this is a good one-stop shop, a compendium where a lot of research is listed. So here are the 3 main deal breakers that I run into or mention to my clients when I come for a home inspection. Outside overhead power lines with high magnetic fields, because shielding is expensive and it's ineffective. I've tried it, it just doesn't work. We've tried it for power, main panels, electric panels, and those are point sources, and they're very difficult to mitigate because the magnetic fields come around the edges of they repropagate around the edges. They don't stay, and you don't eliminate the fields, you just compress them. and they do bleed right through the material. And it's a space-age material called mu metal, made of nickel and a nickel alloy. It's expensive, and it's really not effective. You can try, maybe for one breaker panel, but that's it. But you have to go, 3, 4, 5 feet in all directions, up, down, left, and right, because whatever you measure at the edge of your shielding, that's what you're going to measure right in front of the panel, just opposite the panel, because the fields bend around. But for a house, for these, underneath these things, forget it. I tell clients, just don't take this house, because we believe that, and we know from research and from experience of our clients, that there is a health risk from this. I know 2 people personally who have cancer from high magnetic fields. One from power lines, well, actually both of them from inside the house. One was current on water pipes, and the other one was wiring errors. Also, the second deal breaker for me is cell towers in close proximity to the house, because you can shield these, but it's expensive, very expensive. It can be done, though, and there are people who I work with who are quite bothered by both of these, and others who just don't want to have that in their lives and for their children. So those are 2. A third one would be this, knob and tube, or ungrounded Romex circuits, like here, where you have cloth-wrapped Romex or plastic Romex from the early days, from the 40s, 50s, 60s, before they put a ground wire in, because they cause high electric fields. And of course, you all know what this is, knob and tube wiring, because you have separation of the conductors. You don't have any cancellation here. Very little, and you also don't have any bleeding off of the voltage from the hot wire by the neutral being right next to it. It's too far away. And when they added a ground wire, then you had more bleeding off, but not for these circuits here. There's only a hot and a neutral. They're together, but there's no ground. So these are things that, this can be fixed, but you have to rewire the house. So these are deal breakers in my opinion. The remainder of the magnetic fields and electric fields can be mitigated, and all houses have them. So I tell people, I'm going to find things. I did a home real estate evaluation yesterday, and for a home right next to some power lines, and I said, it's okay here. They're not that strong. This is a spur that does not carry a lot of current. It's not going to get very hot because it's close to the ocean, and they don't use air conditioning much there. So whereas that does rise in the summertime, and you have more electric current flowing, and you'll have an increase in magnetic fields then if you're near power lines. So these other sources that can be mitigated include AC magnetic field EMFs from wiring errors, current on grounding paths, and point sources, transformers and motors, and then electric fields from plastic Romex in the sleeping areas and ungrounded computers, and then radio frequencies from wireless devices in the home. And that's an area where we get a lot of pushback from our clients. They say, oh, don't tell me I have to give up my Wi-Fi. I said, well, it's up to you. Let me just tell you what the facts are. You'll thank me 5 years from now for listening to that guy in 2015, 2016, because by then people will know about this, and you'll start getting calls from your friends saying that their son is diagnosed with a brain tumor because it's happening. So we just recommend hardwired connections whenever possible as a precaution for those who are not symptomatic. So here are the basics for magnetic and electric fields. Magnetic fields are produced by electric current flow. So it's like water coming out of a hose when the spigot is open. So, and it's visualized as closed loop lines around electric current flow. That's the magnetic fields. The electric fields are produced by voltage, which is the pressure, and they're the energization of the space between voltage differences as opposed to the energization of the space around electric current flow. So electric fields are a little bit harder to grasp, and hardly anyone measures them except us, but they do affect your health, particularly where we sleep. And they're, the analogy that I use is turning on the spigot is like turning on the breaker at the panel. You've now energized or pressurized the hose with 80 pounds of water pressure up to the nozzle, which is not yet squeezed, so there's no flow. In the same way, the light is maybe plugged in, and you don't have the light turning on because you haven't turned the switch on. When you squeeze that nozzle, the water shoots out, like over here, at 80 pounds of pressure. When you turn on the light, the electrons flow and light up the filament. But when you turn off the light, it's like letting go of the nozzle, and you feel the kick. Everyone feels that kick of pressure from the pressure up to the hose, And in the same way, as you'll see later, the pressure of the voltage, 120 volts, is there right up to the switch. And that causes a field that comes out 6 feet in homes. And I'll show you that when we get to electric fields, that interferes with your sleep because it causes a push-pull, attraction, repulsion of the electrons and protons and the charged ions in your cells, the potassium, sodium, calcium ions that are charged positively or negatively. And that affects your sleep and your health and the depth of sleep overnight. So AC magnetic field basics, I've mentioned that as you have flow through here, the electrons will go clockwise, the protons will go counterclockwise. So my teacher, by his own admission, he did this wrong. I pointed it out to him and he said, okay, those protons. The right-hand rule says these should go clockwise, but there's direction to it. That's what's important. And there's opposite direction of the electrons and protons around the two conductors. The hot, it goes out, the neutral comes back. That's the only difference between this and the water hose. This is one way, this is two way. You have to have a flow, and there's no voltage on the return side. The voltage is consumed by the load, but the current comes back, and they both produce magnetic fields. And the amount of current here, whatever it is, that's how much you have to have over here. If you have less or more, you're going to have a net current, and I'll show you that. So magnetic fields only occur when current is flowing. It's like the flow of water through your garden hose. Now, the field decreases with distance from the source. It extends only 2 to 4 feet from typical point sources, like transformers and motors in your breaker panel. And it can extend 6 to 10 feet from current on the grounding system, which is what happens. I'll show you that, and we don't want that to be present. And then it occurs when wires are separated, like knob and tube wiring. But those fields cancel when you have typical Romex or Flex or EMT, where you have conductors together. And it's very difficult to shield. This is mu metal. It's heavy. It's hard to work with. And as I said, the magnetic fields will come around the edges and come back to where you're trying to protect yourself. It's best to eliminate the source, like shut it off or turn it down, or move yourself away several feet for point sources. So distance is your friend, or not by the house if you're under power lines, as far as we're concerned. And we say 1 to 2 milligauss is the safe level. So here are the 4 sources of magnetic field exposure. Overhead power lines, because you don't have cancellation, because they don't insulate these. So they have to separate them so the wind doesn't knock them together, because they're bare. And you don't want to live anywhere near these things. And how far? Well, my profession says a half a mile, but I've measured low levels well within that distance. So it just depends on what your meters show. This is a point source, an electric meter. This is a point source. There's a transformer in there. There's a transformer in here. So these are point sources. Then we have wiring errors, and I will show you this in just a minute, but this is a wiring error, and this is a home of a client of mine. We have current on parallel paths. Knob and tube wiring is another problem. And then current on the grounding system, where you have the code-required bonding of a grounding conductor from the panel to the water pipe as a lightning path if lightning strikes this house. You have the ground rod here. You have current going into the copper pipe or steel pipe, galvanized pipe under the front yard, and that's a grounding path, or earthing path for lightning. But that metal pipe is connected to a metal city water main, connecting, therefore, all the houses on the block on both sides of the street in terms of their electrical systems. And remember, in the breaker panel, at the point of egress, current flows on the ground wire, on the neutral wire of the electric drop service, but it can also go on the grounding path because you've now given that electricity a way to get back to that transformer through the neighbor's house. And electricity takes all available paths that you give to it to get back to the source. So here we go. Electricity takes all available paths to get back to the source, not only the path of least resistance. So electricity does not take the path of least resistance exclusively. It takes the path of least resistance primarily, but it will go on other paths. And if you have current flowing on this ground wire, which is in the attic or in the basement, in the joist underneath your floors, or where I live, we don't have basements, it's in the under the crawl space or up in the attic, there's a field that's around this that can extend several feet into the living space. Could be right under a bed or a desk or a chair or a couch, because there's no cancellation. There's no path going the other way with an equal amount of current as what flows on here. And these two houses are together. They're bonded together. All the houses are. They're all sharing some amount of electricity. So you take a clamp meter and clamp around this right in the front of the house, because where I live, the water pipe comes out of the ground and then turns 90 degrees and goes into the house, and I can clamp right around that. Or if it's a cold climate, you can go in the basement and do this. And there are mitigation steps that we can do. This is a fixable form of magnetic field exposure. The other path, which we don't show here, is the TV cable sheathing, because it's grounded at the house and it's grounded up at the utility end of the TV cable. And that's another potential parallel path, but that's fixed with a simple $15 ground loop isolator that you can put in yourself, or the client can do it themselves. Now, location is important here. The service drop configuration. So here's the weatherhead here for this house, and it drops down, and there's the meter, and here's a service panel. It may not be the main one, it could be a subpanel inside, but this is not a good location if this is a bedroom. And that's quite common in the Southwest, where I live, to put these on the back of the house, and there's a bedroom right there. This is a better location, much better. It's on the side of a garage. And here's the best, if you can do it. It's out in the yard. It's on a pedestal. Now here's some meters that you can purchase to measure these. On my website, I have a page, EMF Meters and Instruments. You can go there, you can read about the EMF meters that I recommend. So depending on how much you want to spend, you can get either a single axis meter like this, or there's one for, this is $35. It's not really professional grade. There's a digital one for $80, $89 that is single axis. The FW Bell is a great Gauss meter, triple axis. It's about 300 something. And there are a couple of other models that I recommend. So go to EMF Meters and Instruments on my website. Also, the Trifield meter here. If you're going to get a Trifield meter, it has to be flat response. Don't get the frequency weighted model for reasons I explain on my website there. And the buzz stick is handy because it makes a noise when you put this pickup near a magnetic field. So I have one similar to this on a stick that's 3 feet long, and I can stand. It's like somebody at the beach with a metal detector, and I sweep this part back and forth across the floor with my Gauss meter in my hand. And if I pick up a field, then I want to know, where does it run? Is it a point source? Is it a linear source? And based on the path that it takes and the nature of it, and what does it go away when I shut off the breakers, that tells me whether it's current on a water pipe or TV cable or a wiring error. And I also will use a clamp meter. I should have put that on this page here, but a clamp meter, then I clamp around the water pipe and the grounding paths, and that helps me figure out what's going on and which tradesperson I need to recommend to the client to bring in, a plumber, electrician, and I come back and work with these folks to mitigate this. Now, neutral to neutral wiring errors are discussed in this gentleman's book, Carl Riley, Carl with a K. He's an electrician from North Carolina who was invited to come to California back in the 90s to look at wiring or magnetic fields in schools, and he headed up a team of electricians. And based on their experience of finding wiring errors, he wrote this book, which is now in its 3rd edition. In the 2nd edition, he said nobody took him seriously when he first wrote the book, the 1st edition, but since then they are taking him seriously. He's getting calls from all over the country, and he's now on or at least was for many years, maybe still is, on the review committee for the NEC revision every 3 years. And he said in his 1st edition in this book that code inspectors should walk around with a Gauss meter, and there's a rumor that that's going to be required of code inspectors in the next revision of the NEC. So that will be helpful. And one more thing, arc fault breakers trip. You guys have heard this. You know that the electricians you work with and you meet hate the arc fault breakers because they're so temperamental, but you know they have their job. But we love them because when if there's a wiring error, which I'm about to show you, if you when you turn that breaker on for the first time, it'll trip. So electricians are learning that they can't do the things that they've been able to get away with before to create these wiring errors. And the reason why they got away with them, not that they're intending to do that, but the reason why they slip through is because code inspectors don't look for them. because nobody cares about magnetic fields in this country. So this is a great resource, Tracing EMFs and Building Wiring and Grounding from Carl Riley from lessemf.com, and also there's a DVD that he made that you can buy from them, 23 minutes long, that he made at the request of the utility out here, Southern California Edison. So here's an example of what we're talking about. This is a neutral-to-neutral wiring error. This box has three circuits in it, and the hots are all separated, you know, because if they're not, there's a 50-50 chance, depending on whether they're on the same leg or not, of the breakers tripping. You know that. But look at all the neutrals. Every single neutral is under one wire nut. This is sloppy work, and electricians, from what I'm told, are taught not to do this in a training, but they do. And what this leads to is a parallel path for return current to get back to the panel, because current will come in on one hot, go to the load, and come back on the neutral that's associated with that particular load, that light. And when it gets here, three of these wires are going back separately, back in the back of this box, to the panel. And they're not all together. They're going in different routes. So you have 3 amps coming in, and 1.5 amps goes back on the neutral of that conductor, where all 3 should go. And the other 2.5 amps is split, or you know, whatever the resistance is, that determines how much there is. And now you get a magnetic field in the house along that route from here back to the panel when these lights are turned on. And in this case, any of these lights, when any of these lights are turned on, you're going to get this phenomenon. So it takes us a while to find this, but when we open this up, and this is we're kind of happy because we can fix this in short order. We just have to trace every single circuit in there. Which ones, how many different circuits do we have, and which ones come from the panel and which ones go to the loads. And then I tell my students that the whites have to follow the blacks and reds. The neutrals have to follow the hots, and separate them, and then you're fine. Now here's an example of that same box. So here it is all together, and here we have the neutrals separated. I guess there were 2 in this case. So here's one circuit, and here's the other. Okay, so neutrals always need to follow the hot conductors and not be mixed with the neutrals of another circuit. Now here's another example from the same house. And here we have a clamp meter, triplet 9200A. You can buy this from Amazon for $35. TRIPLETT 9200 capital A, $35. It's a great little meter. It gives, so this is 1.9 amps net current between this hot and neutral, because they're on the same circuit. I traced them back into this box. This is before because all of these are together. This is another part of the house. And here they're separated. So now the same pair has 0. I don't know if you can see that, but that's 0 now, with the load on. So what you first have to do is turn the loads on, and of course we have the cap off of this neutral, but we're still doing our work. But you clamp around the black to make sure you have current in the first place. Because you have 0 current on black and 0 on the white, then you don't know that you don't have a wiring error. But if you have current on the black, and then you want to see if you have 3.2 amps on this, you better have 3.2 amps on this, because if you don't, you're going to get this. All right, so here you could have lower current on this or more. I've seen situations where there's nothing on this black and there is current on the white. That's because of mixing over here. So these are examples that Carl talks about, and here's some pictures of wiring errors, neutral to neutral. Now here's another way to measure. This is the Trifield meter showing that we have an elevated field here, and then after the wiring error is fixed, the current is still on, but there's no field. Now this is another type of wiring error, neutral to ground. So what you see here, excuse me, is this. Many of you have seen this. This is not good. This is not code. This is not something that people should do. Electricians should not do this. but it's done all the time. Excuse me. So the solution is to remove this ground and obviously ground it to the box and separate the neutrals from the grounds here. Here the green, you can't see it as well, but the green ground wire is under the neutral of this wire, not here. So you may have a problem here because this may be the only return path for the current to flow. And if that's the case, you have to run another wire and get a ground in there. This is another situation. This is the best image that I could find on image search. So assume that this is a subpanel. And here we have bonding of the neutral bus to the back of the box in a subpanel. It should be like this, not this. So this is another example of a wiring error. Now, down below here, this is an example where I show you neutrals and grounds together. There's only one box in the house where this is allowed and should be present, and that's the main panel at the start of the service. If this is a subpanel, this is a problem. All those grounds need to be separated off this neutral bus, put on their own bus, bolted to the back of the panel, and you should make sure that you don't have a bonding screw or one of these straps. This is a situation where I saw a circuit in a box with a neutral just hanging there by itself, no cap over it, and not going anywhere, not attached to anything. And there was current on the hot. It's obviously a problem, and we had to rewire this situation. So what you can do to screen for wiring errors is get a Gauss meter, hold it 2 feet above and 2 feet out from the wall, 1 to 2 feet above, 1 to 2 feet out, turn on the load, and see if the magnetic field goes up. It should be low to begin with, and we like the fields to be below 1 milligauss, ideally. In this case, when you have a wiring error, it will go up quite a bit. The current on grounding paths is something that should also be avoided, but I mentioned it earlier on, it's because we're allowing current to get back to the panel. And when that happens, then you have less current returning on the neutral of the service drop for the electric utility than coming in between the two phases or legs. So if you have 8 amps coming in, you want 8 amps going back. There's always a little bit on the soil, so maybe you'll have 7.95, like maybe 50 milliamps net difference, but not 1 or 2 amps. And I see that often because you'll have half an amp, 1 amp, 1.5 amps on the water pipe or between the water pipe and the TV cable. Those are all fixable. We love PEX. We like plastic wiring in the house, but that's not essential. You can have copper pipes. You just need to have, you need to make sure that you don't have current on, excuse me, on the grounding path. So this is another thing. Choose not to live near high tension power lines. Don't sleep near electric meters or breaker panels. Don't sleep or sit on the other side of a refrigerator. You don't want to have the transformer for low voltage lighting near your bed. The magnetic field comes out about 2 feet, and that's magnetic fields. So I'll go over electric fields briefly. We're running out of time, and I want to take some questions. But electric fields are produced by voltage. They're measured with a voltmeter, not a Gauss meter, and they're due to pressure. I mentioned that earlier. And this is what clients don't know this. They think that the EMFs, as they call them, because they don't know that there's a difference, come out from the receptacles. They don't realize that the electric field comes from the Romex, the unshielded circuit in the wall, but also from power cords for the bedside lamp. The electric field comes out 6 or 8 feet. It has an effect that far. It decreases with distance, and it affects people while they're sleeping. These are really hard on your health. Electric blankets and the electric heating pad for a waterbed. These are the meters that you would use. This is a nice one designed for building biologists, $2,000, but it's great. It's three axis for magnetic fields and triple axis for electric fields. This is a single axis meter. Gigahertz Solutions makes these available from Safe Living Technologies. And this is the body voltage meter. This is why we do this, because when you eliminate electric fields, you spend more time here at stage 4, the deepest part of sleep, every 90 minutes through sleep cycles. So you have one sleep cycle, for the red and the blue together. It's a non-dreaming and a dreaming time. Non-dreaming, dreaming. Non-dreaming, dreaming. The more time you spend here, the more rested and refreshed you feel when you wake up. And these are the symptoms that clear up. Fatigue, fibromyalgia, and so on. And this is what happens. These are some of the things that happen. And again, I will have these slides on my website so you can read them in more detail. These are some comments that people have mentioned. And this is the ideal. If I'm consulted on to help with the design of a home, and depending on how what the budget is and how sensitive my clients are, we may use this in certain parts of the house because this reduces even day and evening time exposure to electric fields. But most people can handle that. It's the nighttime that we want to reduce that. But you can do that with Romex with a cutoff switch. And these are some other things. We have remote switches. If you have metal clad wiring, you can use this. We have shielded wiring. All of these are the tools of the trade that we use. And we have the earthing pad. There's a lot of controversy about this, and I won't go into detail here, but if you have questions about that, you can email me. And here are some of the things that people can do in their offices, home offices. You want 3-pronged plugs, not 2-pronged, for your computers. If you put your hand on a computer that is powered with a 2-pronged plug, you're asking for a very high electric field which will drain your energy, and you won't be able to focus, and you'll wonder why you're so tired after a few hours of working on that computer. You want this, and you want the outlet to be properly grounded, so you need one of these, which you guys all carry. So these are some of the things, and Mac has this little adapter here, although they're taking that out in the new model, from what I understand. This will be hardwired into their transformer. This is what you want, not this 2-prong thing. You want this at the end of this cord right here, if you have a Mac. So I'm going to stop at that point because I can't get into radio frequencies today, but Ben, I'm going to open it up to questions.
Sure, and you can keep the slides because the answers to the questions, you may need to refer to your slides again. So we have David. He said, I hope you're going to discuss or provide information for further learning and education regarding how to shield, eliminate, reduce, etc. these harmful EMF levels. He's extremely interested in learning more about this stuff for his future clients. I think we went over many things about that information. But where would someone go to get more information? Would it be your website? Do you have that URL?
Well, here it is right here. CreateHealthyHomes.com. Homes is plural. It's all one word. Create Healthy Homes. And at the tail end of this webinar, I have a summary of EMF Basics. Then I have a summary of steps to reduce magnetic fields. So this answers Dave's question in summary form. Same thing for electric fields. Same thing for radio frequencies and dirty electricity, which we didn't get to. Perhaps we can schedule another webinar for that, and I'll be over this cold by then. Apologize for that. But it's all, I will be going over this at Inspection Universe, and also you'll see it on the slides.
Wonderful. Oram, we really do appreciate you trudging it out through there. We could hear you struggling a little bit. So thanks for being with us. But we do have a couple other comments and questions, and we do have 10 minutes left. So Brian says he wanted to make the point that we don't tell our clients, our home buying clients, not to buy a house. We just provide them with information that they can use to make a smart decision, whether they buy the house or not. We try to stay away from that. So we actually, as home inspectors, if we're doing a home inspection, we don't actually say, oh, overhead power lines, don't buy this house. So we just want, David wanted me to make that point that we don't, or Brian wanted me to make that point that we don't tell anybody to buy a house, particularly with, maybe potential EMF problems.
Well, that's a very good question, and I try not to get into that myself. I only bring it up because people press me for my opinion.
Yeah. Yep.
And I'll tell you what I really dread is to say, well, it's marginal, but go ahead, and then have them contact, which has never happened, and hopefully it won't. But I don't want to get a call or an email or a letter from an attorney, 5 years later saying, well, my son developed cancer, and you should have warned us about this. Or we hired somebody else, and he said, oh, this is just too high for you. I'm very careful about this, and I say, you have to make this decision. Here's the data. Here is the consensus of EMF safety experts around the world. And generally, it's 1 to 2 milligauss. Now, that varies. That can vary from the morning to the evening to the night. Whatever you measure in the daytime when you're there for your inspection, or I'm there, it's going to double at night when everyone gets home and turns on all their loads.
Yep.
And then it drops 25% below the afternoon level at night from midnight till 6 a.m. when everyone's turned everything off, except the refrigerator and the furnace. So you can gauge that, you can tell people to expect some variation based on those numbers, doubling in the evening and 25% less in the afternoon. And then in the summertime, everything is higher because of the air conditioning, which pulls more current on these neighborhood and particularly the larger distribution lines.
You know what this sounds like a little bit? It reminds me of radon gas. So home inspector,
right.
A lot of us are certified to test radon. Radon fluctuates. It comes in different places. There are ways to mitigate. There are affordable some steps to take. But what we do is you go in, you capture the measurement at that time, and you can't really predict what's going to fluctuate in the future. But you give the client information based upon your testing and at the time of the test.
And you can take 2 or 3 measurements and then either average them or better yet, take the highest one and advise them.
You mentioned a certification, and also there's standards about, we don't want inspectors to just go in and as a home inspector and just start getting their meter and start taking measurements and not knowing what to do. There are standards and training and guidelines and certifications, right?
Oh, yes, and I need to add a slide to that effect. If you go to my website and click on Building Biology Safe Exposure Guidelines, there you will see a listing of the guidelines that we recommend, which are based, actually it comes from the European building biology profession, and with their blessing, we said, can we use them and without having to reinvent the wheel, and they said absolutely. So, and that was just updated this year. The numbers are the same as they have been, but they changed the wording a little bit. But if you go to Building Biology Safe Exposure Guidelines, you'll see there, for instance, for magnetic fields, we break everything down into 4 categories. For sleeping areas, we don't have separate guidelines for daytime exposure. We have them for sleeping areas, which are the most stringent, and we build from there. So we have no anomaly, slight anomaly, severe, and extreme. So for magnetic fields, it would be 0.2 milligauss or less is no concern, no anomaly. 0.2 to 1 milligauss is slight in the sleeping area. 1 to 5 is severe, and 5 and above is extreme. And I have an article or a section of the article on magnetic fields. If you go to Articles on EMFs on my website and click on the separate link, the link for the separate article on magnetic fields, there's a section there where I talk about the difference between various countries on magnetic fields. For instance, there is no standard in the United States for magnetic field exposure. The International Commission for Non-Ionizing Radiation Protection in Geneva, which is supposed to be independent, but people that, smart are activists and advocates in the EMF safety community point out that there's a lot of funding by the electrical industry of that organization. So anyway, that's what they say. And they say 833 to 1,000 milligauss is safe, and that's quoted by one of the electric utilities here in Southern California. And so, but they have all rights to say that because that's what this agency says. But then you have another level, another tier. Switzerland says 10 is safe, their safe level, and we still think that's too high, but that's what they say. And Brazil has adopted Switzerland's level. Sweden is 2. Israel, I understand, is 4. And the Austrian Medical Association says 1, and we say 1. We like people to be below 1 milligauss. So 1 to 2 milligauss is considered a relatively safe level for healthy people by the general international EMF safety community. And then we have the same breakdown for electric fields and the other forms of EMS.
Why don't you get to the slide where your website is so people can...
Oh, sure. Yes, that's for at the very end here.
Andre says, Andre brings up a really good point. As home inspectors, we're not required to inspect the inside or pull the dead front cover off the main electrical panel. We're not required to open it and inspect even switches, pull out switches and receptacles and the wiring. And we don't, Andre says, we don't enforce code. We're not code inspectors, not the township code inspector.
Although I've seen many many home inspectors open that up. I didn't know that. Yep. I thought that's pretty common.
The question is, the answer is, we're not required to.
Okay.
Many inspectors are on the minimum standards and do open the electrical panel. Very few, I would say, will pull out a switch. Although if we're really asked by our client to find out the knob and tube or the wiring type, looking for aluminum in a 1970s house, we'll do that for them.
Well, yeah, there's a lot you can learn by opening up the panel cover,
yep.
Or even the cover of an outlet here or there or a switch. Actually, I'm of the same mind as you gentlemen, and that is, and ladies, that is, when I do a real estate inspection, it's like, a couple of hours, like your inspections are, not quite as in depth. When I'm with a client who asks me to come to their home where they've lived there for a number of years, then I'm there all day. But when I do an inspection of a home that someone's interested in buying or leasing, then I note things, and I have 2 things in mind. One is to tell them whether they have deal breakers, as I mentioned, and assuming there are none, then in which case I'll say I really don't recommend that you take this house, or here are the things to consider. But then I'll note the other things and put them in the report, because if they do buy the house and they do want reduced EMF levels where they live, where they're moving into, then I'm sort of making a checklist of what I'm going to have to deal with when they do move in, particularly in that interim period between taking possession and actually moving in. We can fix wiring errors. We can, mitigate the current on the water pipes. Put in remote switches to shut off breakers near where they sleep. Those sorts of things. So I'm paying attention to that too, because I want to know, well, what is it going to cost? What's your estimate, and what do you have to do to really make this place safe for me? So I do have a mind towards that when I'm going through. Whereas home inspectors are not really going to be coming back and doing follow-up work. That's for other tradespeople. So I understand that there's a difference. You guys are not you may be electricians, but you're not doing electric work. You're a home inspector, and I understand it's a different process than what I am involved in.
Well, Oram, we are at the end of our hour with you.
Okay.
I want to thank you very much. It's been a real pleasure, eye-opening experience. I'm glad you came to InterNACHI, and you are going to be, once again, at the Inspection Universe in Orlando, Florida in March. And for those folks who don't know where to get that information, it's on the screen. I hope you can see my screen. It's at nachi.org/universe 2016. And our classes are at nachi.org/webinar. And just as an extra URL I can give you, go to nachi.org/everything, and there you'll find everything you need to be successful as a home inspector. Oram, thank you so much. Everybody, thank you very much for attending.
You're welcome.
everybody will get a link to a live recording of the Oram's class here. And thank you so much. Goodbye, everybody. Thanks, Oram.
You're very welcome. Thanks for inviting me. Goodbye, everyone.
Bye.